Have you ever jumped up really high and floated through the air like a bird, or gracefully flipped and twisted like a tumbling gymnast, or maybe just fallen flat on your face? No matter how you move through the air, though, you always come back down to the ground. So what keeps us grounded? Here on Earth, we're all pretty familiar with gravity, the force that pulls everything toward Earth's center. But what is gravity exactly? And why doesn't it pull us apart from Earth? To answer this question, we have to look deep into the heart of our planet. First, let's take a moment to appreciate the awesome power of gravity. Without it, Earth would be a very different place. It would be a lot less round. It's actually the force of gravity that pulls Earth into its spherical shape. Without gravity, we couldn't walk, run, jump, fly, or even breathe. It's gravity that keeps our atmosphere close to Earth and not floating out into space. It also keeps our oceans from boiling away into space. But let's get back to the question at hand. What keeps us from floating away? Or to put it another way, what keeps us grounded? The simple answer is mass. Everything has mass, including you, me, our homes, stars, and even planets. And the more massive something is, the stronger its gravitational pull. Take a bowling ball, for example. A bowling ball has a lot more mass than a soccer ball. So when you roll the bowling ball across the floor, it'll knock the soccer ball out of the way. That's because the bowling ball has a stronger gravitational pull than the soccer ball. It's like an invisible force field around the ball. But what does this have to do with us? Well, everything on Earth is made up of tiny particles called atoms. Atoms contain even tinier particles called protons, neutrons, and electrons. And it's the protons and neutrons that have mass. And therefore, they have a gravitational pull. Everything on Earth is attracted to other things with mass, and we can experience this force as gravity. We know that Earth is very massive, so it has a strong gravitational pull. In fact, Earth's gravitational pull is so strong that we can feel it on the soles of our feet, pushing us down to the ground. But if we were far away from Earth, like in outer space, we wouldn't feel any of these forces because there is nothing around us to pull on our feet. When we jump, we're actually using gravity to help us fly through the air. When we jump, we push down on the ground with our legs, and the ground pushes back up on our legs with an equal amount of force. This is called action and reaction, or as Sir Isaac Newton might say, for every action, there is an equal and opposite reaction. Newton developed his theory of motion in the 17th century. He described the force of gravity as a force of attraction between objects with mass. The more massive an object, the stronger its gravitational pull. So when we jump, the ground pushes back up on our legs with an equal amount of force, propelling us into the air. Once we're in the air, though, we're no longer being supported by the ground. So we start to fall back down to Earth, and the faster we fall, the stronger the gravitational force pulling us back down to Earth. Eventually, the force of gravity becomes stronger than our legs can push against it, and we land back on the ground. And that's what keeps us grounded. So the next time you go for a jump, remember that you're not just using your legs to propel yourself through the air. You're also using the force of gravity. And if you ever find yourself floating through the air like a bird, or gracefully flipping and twisting like a tumbler, or maybe just falling flat on your face, just remember to keep your eyes on the prize and land safely back on the ground. After all, it's the force that keeps us alive. Do you have a burning question about the universe that you'd like answered? Submit it to the link below, and it could become a future episode of Seashow Space. Until then, we've got lots of videos about the amazing things that happen right here on our home planet and beyond. So click here to watch this video and click here to watch this one.